Uh, Thank you for coming over for the last session. I hope you are still healthy enough to listen to one more talk. Okay. This talk is about databases and continuous delivery of databases. So before I start, just to get an idea of what kind of audience I have, how many of you are actually programmers who write code, who break code? Okay. And because I do that all the time. And how many of you actually interact with databases or no? Okay. Oh, that's a good enough time. Okay. So, few years back, I was working on a product. The product was about custom designing things. Okay, so you can come to the site. It's a website. You can come to the website. You can design your goodies, be it a T-shirt or a mug. Okay, you can say that okay, I want this particular image on this part of my goodie, and I want this text on this part with this color. And it's not a new thing, but at that point of time when we were building it, it's a newer idea. Now I think we see a lot of products doing this. So you can come there, design the thing, and say how many items you want, check out, and the item will be delivered to you by shipping. And what happens in the background is the designs that you create gets converted into a PDF, which is actually given to the printing vendors, and they print it on the goodies and ship it out to you. Okay, so what you see on the site on the website has to be clearly printed on the PDF exactly in the way, including the color, the gap between the items. Everything has to be pixel perfect so that the printing vendors can print it correctly. And as we know that we all work in this industry, we know that the change is only constant. Okay, so we used a certain library to convert what you see as an HTML into a PDF, including the fonts, the colors, everything. But when we were working on a certain text features like the rotation of text, the angles of the text, we realized that the library that we were using is not doing it pixel perfect as we expected. So we had to change that, but the other features, the images and other things were working fine, except certain features for the text. So we have a lot of features that we already built, but for the thing that we want to add now, that the current library doesn't support that, or it's not sufficient enough. So we found that there is another library that supports that. So how do we make a choice, because we already have a lot of things built, we want new things to add. So how do we support both in a manner that it doesn't bring down the features that we already have in the system? So what we did was we took both the libraries and we did parallel implementation. For the newer functionality, we use the new library. The existing functionality, we continue to use the earlier one. Okay, and we gradually moved the earlier functionality to the new library. This gave us enough confidence to make sure that the newer library is not bringing in any surprises. In case there is any surprise, we could go back because we already have the earlier library in our repository. Okay, so to achieve that, we created a abstraction layer which decides what library to use for what feature, and then the killing of the earlier library was done by changing the abstraction layer. It's as simple as that. Okay, and then over a period we completely moved to the newer one and killed the earlier implementation. And this idea is not new. This is the concept. This is the pattern called branch by abstraction. Where you branch, instead of creating multiple branches in your repository, you create branches within your code to decide what library to use for what. Okay, and the fundamental to this is refactoring. That is, you change the code, you refactor the refactor the code to the newer implementation or a period and then kill the earlier implementation and get rid of the earlier implementation completely. And this is the fundamental to refactoring. Refactoring is in small steps. You don't do a big change using refactoring. You do it in small steps, and the test will give you the confidence that okay, the small changes that you are making is still working. It's not breaking anything in the system. And what it allows you to do is continuous delivery. That is, when you make a change. So in our case, what happened was we introduced a new feature. We have the new library. We released that feature. We have the old library as well as the new library, both in parallel. And then we continuously delivered the changes into the production. That gave us the confidence that okay, nothing is broken and the new library is as good as the earlier one for the features that we have already built. Okay, so these two together was giving us gave us the confidence to move the library that we were using is a major part of it. If something breaks, it's a big deal for the business. So we cannot take a risk of breaking anything in the production which is already working, especially, right? And the branch by abstraction, which fundamentally uses the continuous delivery and refactoring, allowed us to do that in a safer manner. So time passed. Right now I'm working on a product called Good Karma. It's a digital marketing platform for wellness industry. Okay, one of the things that if you have worked on startups, one of the things that it demands is evolving, right? When you start with a certain idea for a product, then you go into the market and then realize that okay, the market wants something else. Then you have to evolve as per the market demands. Okay, that too while you are serving customers, existing customers, you want to evolve it depending upon the market demand, and it's like the person throwing balls in a unicycle. You have to balance the cycle as well as you have to catch the balls. Okay, and and then how do you do that for a database? Right? When you have a lot of data in your database, you are making drastic changes to your applications. How do you, because the problem with databases is considered as very slow, right? And then if something breaks, that breaks the entire application, right? And then you cannot lose any data. And then if you're making major changes and if you're losing data, that's a big problem. It's not like as simple as making some code changes, right? So, and it is high risk also. But from the data, when you think about databases, what the first thing that comes to your mind is the asset transactions, the kind of safety that it provides, right? Either it commits everything or it rolls back, right? And this idea we have taken to atomic deployments, like when you use tools like Capstone or say even past services like Heroku. When you say git push to Heroku, it does the entire deployment. If there is a failure, it completely roll back. These kind of things we have seen, and it is very safe for us, right? I mean, the thing is that you know that either it is done completely or it is not done, right? How can you bring such kind of a safety into doing database changes, right? How can you make very safe or less risky schema changes to major part of your database without thinking of without being afraid, right? How can you do that? Can we actually apply the refactoring concepts there also? Is the question that started popping in my mind when I started working on my product. Okay, and that is where the database refactoring comes into picture. I don't know how many of one of the things that I've seen is that a book came out with the name Database Refactoring long time back, but people have not actually given people have not noticed that enough, because it came out much earlier than continuous delivery, but what it allows you to do is make major changes to your database in a manner which is safer. Okay, so I've been talking a lot. Let's look at some examples. Okay, so in our application, we have we allow people to book trials, trial classes with our customers. Okay, so they can call up the sender and say, okay, I want to come and take a trial class at the studio, and then what happens is that some of them turn up, some of them don't turn up. Those who turn up to the trial class, they may register with the sender. Okay, so we have this schema where we say, okay, this is a person who came in, he booked the trial on this date, and the status which says that whether he has attended the trial and also whether that person, he or she has registered with the sender. Okay, later we realize that the status is doing too many things. It talks about two things. One is that whether that person has attended the trial and also whether that person has registered with the sender. So we wanted to break it into two different fields. Okay, the attendance status and membership status. So when you do such a refactoring, what we usually do is we remove the earlier field, we split this data into two different fields, okay, and then start using that. But if you do make such a major change in your application, then what happens is that there will be downstream dependencies in your application which may use the existing field, and then those will start breaking. Okay, so what in this kind of situations, what is actually recommended, or what we approached, what we did was we kept the old field and the new field, like the branch by abstraction what we saw earlier, where we have the old implementation and the newer implementation. Okay, so we added the new fields, we migrated the data from the old field to the new field, and then when any part of the application changes data to the old field, we make sure that that data is also reflected in the new field using database triggers or any other patterns that you want to use. Okay, and then once we completely migrated all the downstream dependencies to the newer implementation, we removed the old field. So the entire refactoring period looks like this. We have the old schema where we have only one field. Then we have a transition period time where we have old implementation as well as the newer implementation. And then we have the new schema where we kill the old implementation. Okay, so this allows us to transform to the newer way in a manner that is especially when you have a lot of dependencies, downstream dependencies, like you have APIs and all which is being used by others, then this kind of an approach really works. And this is also safer because if something happens during the migration from the old to the new ones, this makes sure that the data is not lost because you still have the old data. Okay, you don't have to recover it from your backup, which might be a pretty bad situation, and then you cannot do that without a downtime. Okay, so this is a safer approach, and this is actually recommended when you're making major changes to your database, especially where you have where the database schema is the crux of the part where you're making the schema changes is the crux of your application. Okay, and this is called the split column. You are splitting one column into multiple columns, and the approach is that you keep the old columns and the new columns, and then once you completely migrate, you kill the old implementation. Okay, there is another type called, we are looking at another example. These are real examples that we had in our application. Okay, so and we did this in this way, and then we found that okay, this is actually very safe. Okay, this is split column, split table, where you want to split data from one table to multiple tables. Okay, so in this case, what happens is that we have a table called billing cycles, where we store the details about who paid and what date and what is the amount they paid. Later we realized that okay, people make payments in multiple cycles. Like if I have to pay for 6 months, I pay for 3 months first, and then later I pay for 3 months. So a customer can make, for a single cycle, they can make multiple payments. Okay, so this kind of a schema doesn't work that way, because what we need is one to many. One cycle can have multiple payments. So then what we did was we created the new table. We retained the earlier columns, but whenever we are saving data to the new table, we make sure that it is also saved to the new table. Okay, using the triggers. And once we actually completed the migration, then we remove the old tables. So the entire refactoring time period looks like this. That is, we have the old schema where we have only one table. When we then we introduce a new table, but the earlier columns are not removed. Okay, it is a copy. That copy of that data is also stored in the new table. And then we have parallelly storing data into both the tables for until we do the complete migration. And then once we are completely moved to the newer implementation, we kill the earlier implementation. Okay, so this is called, when you are splitting an existing table into multiple tables, this kind of an approach works. Okay, where you save data to both the tables for a duration, and then you get rid of the old implementation. And this is actually called the expand contract pattern. You expand to both the implementation, and then you contract to the newer implementation. Okay, and this is similar to the branch by abstraction, where you have parallel implementation, and then you kill the old implementation over time. And the database refactoring book talks about a lot of refactoring techniques similar to this. In some of the cases, the expand contract pattern makes sense. In some of the cases, it doesn't. And then you can take a look at, you can use it as a reference whenever you want to make major changes to your database, and then see, okay, what is a better approach to, for example, how do you introduce null, not null constraint to a null field? Okay, what is the approach that you want to do? Okay, how do you delete a column, right? So you mark it as delete first, and then after some time you delete it, rather than just deleting it on a day, because there will be dependencies. So all kinds of techniques are mentioned in the book, and then you can apply it whenever, depending upon what kind of a schema change you want to introduce. But what do we need as a basic for supporting this kind of refactoring? One is that all schema changes has to be versioned. Like your code, the schema changes are also has to be there in the version control, so that at a point of time you can get a specific database version. Okay, for a certain code, what is the database version that you have, that you should be able to know it from the repository. Okay, so most of the currently coming ORM frameworks support this by using the date stamp, the current timestamp as the version code, because it has to be unique. A version has to be unique, like your Git versions. Okay, or else when you are creating new migrations, you need to attach a unique version code to the schema change, so that you can identify those and then either go back to that version at a specific point of time, or you at looking at the schema versions, you know that what kind of a version is running on the production right now. Okay, and we need automation to make sure that when you deploy, the migrations are also run. Okay, and you need enough test coverage to make sure that the schema changes, especially when you're dropping a field or dropping a table, those are not breaking anything. Okay, so enough test automation has to be there to make sure that it doesn't, to give you the confidence that, okay, the changes in the schema is not affecting the application. And you need a strategy to make sure that how do you, when you expand to the newer implementation, but what is the time period required for contracting to make sure that, otherwise what will happen is both the implementation will go on forever, and then unnecessary code is a candidate for technical debt. How can you avoid that? Okay, so that there are only guidelines, that is you as a team has to decide like what should be a good time for contracting to the newer implementation, right? That is something that you may have to decide as a team, and then keep looking at that time period and making sure that okay, it is actually working. Okay, some cases the expand contract pattern might be an overkill because of this extra code that it adds up. So if the schema change is not that very critical, maybe you can avoid this. But to be on the safer side, because especially when you are actually migrating the data and there is a chance that if something goes wrong, the data loss should not happen, it is better to be on the safe side. It is better to apply expand contract pattern. Okay. I thought I'll share some of the good samples that I found, or actual cases where companies have used parallel implementation to make major changes. Okay, so a few years back, and this is these are something that I've seen from the internet, and then I will be sharing slides so you can look at and then read the details from the links that I've shared. So GitHub, one of the key thing in GitHub is the way it gives you the diffs, right? When you commit something, it tells you okay, what is the change that you made compared to the earlier version, right? So a few years back, what happened was GitHub had an issue with that library, that it was taking a lot of time to actually show the diff, and which it was not actually acceptable time that it was taking to show that diff. So but they wanted to change the library, but changing that library, and if something breaks in the production, it's a critical part of the business. So what they did was they did parallel implementation, and then they did something like dark launching. They implemented the diff logic in 2 places, and then they ran it in the production in the background for some time, and then they measured the differences between the newer implementation and the earlier implementation, and they tuned the newer implementation until they make sure that okay, it is actually as good as the current one. Okay, and that happened in the background, and then the users didn't know about it, and then they didn't have to, and then running it in the background actually helped them to gain enough confidence to release it when they actually wanted to release it. It was actually very good in a shape that it was good to release. Okay, so the idea of parallel implementation actually works in this case. And then another case I found is that when GitHub upgraded Rails, the Ruby on Rails, the framework that they use for the front end, they had a pretty old version, 3.2, I think, until 1.5 years ago. And then when they had to upgrade to the latest version, which is 6, it was a 1.5 year project for them. But they actually released to production instead of working on a branch, source code branch. They actually had both Rails version running on the production for a prolonged period of time. And they did branching at the code rather than running a long-running branch in the source code. Okay, so this also gave them a lot of confidence when they upgraded to the latest version of Rails. Okay, and so when you're actually having a lot of major change to the application, especially to the architecture or the design, like framework changes, you can use concept like parallel implementation. Okay, so in that way, rather than running it in the background, you can actually run it in the production and see, okay, what changes is the changes affecting anything in the production. Okay. And in this article, it is mentioned that the expand contract pattern for database changes is something that Facebook and Google uses a lot, so that the changes to the schema is always safe. Okay, and anytime there is a change in the schema, I think Facebook, at least this article which was released a few years back, says that okay, any schema changes in Facebook goes through this expand contract way, the parallel implementation way. Okay, The similar thing can also be used for killing monolithic applications. Okay, you create smaller, newer applications using microservices, and you kill the old application, and then once you completely move to the newer applications, you can kill the earlier one. So this is called the strangler application pattern, which is usually very common for killing monoliths and creating microservice application. Okay, so just to summarize, things will always go wrong in production, and then we need enough hooks to make sure that, okay, we can always go back to the earlier implementation. And then especially when you're making a major change like schema change or a architecture change to the application, it has to be done in a very small step way. You have to lower the risk of releases by doing it in small reversible steps. You can't be, it's always suggested to do a small steps rather than making a big bang change in the production. Okay, because if things go wrong, it will be very difficult to roll back. Okay, and all the references, all the concepts that I mentioned in the talk are mainly from these books. Okay, which can be used as further references. And these are some of the articles that I referred during my talk. And that's it from me. I think we have time for questions. Right?
We have time for questions. If you got questions, please approach to the mic.
Hey, great talk.
Thank you.
I had a couple questions.
Yes.
Have you ever given thought to, say, versioning the table names along with the schema as a whole, and then doing like a dual channel write from the upgraded apps and the not yet upgraded apps would write to the old table, and then you would be able to sort of zip things up?
Versioning is usually done for the schema, current schema, and so it's not at the table level. Is that what your question was?
Well, I was suggesting it having both schemas live at the same time in the database. Only the new apps will write to the new schema. The old apps will write to the old schema, and then when the old apps have been retired, you can copy from the old table into the new one, right?
I've not tried that. Okay. Usually the versioning is for a specific schema that production uses.
Got it.
Okay, and if you want multiple tables, you can have it in the same schema itself, and then you can just rename it and then.
The other question I had is, have you heard of the Confluent schema registry? And did you use that in the transformations at all?
No. Okay.
It supposedly guarantees forward or backward compatibility depending on how it's configured, and you register your schemas with the daemon. It's pretty neat.
Sorry, I didn't hear.
So it's a service, and you register your schema as the new version of the old one, and it will tell you, based on how you've configured it, you can guarantee forward, backward compatibility, or both.
Okay, no, I'm not. Okay.
Hello, thank you for this talk. I have a very general question. Do you have any tips for how to apply these techniques when migrating to a new type of database, like from Postgres to MySQL or SQL to NoSQL?
I think the branch by abstraction concept that I mentioned applies there too. You need to have an abstraction layer depending upon what kind of a database you want to talk to. And then, for example, if you are currently using Postgres and you want to, or say you are using an RDBMS and you want to move to a NoSQL implementation, then start by applying that in the abstraction layer. As you move the tables to the or structure to the new ones, you can change the abstraction layer accordingly. I've not done that, but I think that kind of an approach might work. Okay.
Thank you.
Hello, thank you for the talk. I have a question about performance. Have you observed any performance penalties during the expansion phase? And if so, is it negligible, or how do you deal with that?
Expansion, I don't think that performance will be a major concern because you can do it in the background. Because when you are doing the expansion, you still not started using the newer fields or the newer schema. So even if it is done in the background, it's still fine.
Okay.
Okay, so that is one of the reasons why this is recommended.
Okay. Okay. Thank you.